Hi everyone. Today we're going to be going over a little bit of comparative anatomy between uh, the greater flying fox, also known as Pteropus vampirus. Uh, Pteropus vampirus is found predominantly in Southeast Asia. There are known to be approximately 62 different species of the greater flying fox. They fall into the bat family, and they are the only mammal that can fly. There are a couple of other mammals that can glide, but bats are the only mammal that actually have the ability to fly. Um, it's notable that they have extremely long fingers. Uh, their arms, their upper extremities, and their hands, the long fingers support a thin membrane, and this is what enables them to fly. They're, all bats, all of the greater flying fox bats fly into the Pteropodidae family. They have extremely good eyesight. They're predominantly nocturnal, but they also are crepuscular. They will be active somewhat at sunrise and sunset, but they rely on their sense of sight. Unlike other species that rely on echolocation, they actually rely on their sight. The Pteropus vampirus is the common name is known as the greater flying fox because their head really resembles that of a fox. And that's a little bit of history about this particular species of bats. Bats in general, there are probably close to 1,200 different species of bats. But again, there are only about 62 different species of the flying fox. There's a number of which are now on the endangered list, and we've already lost a few in our own lifetimes. So what I'd kind of like to do is just quickly go over some of the anatomy here, and we'll compare it to that of the human skeleton. It's actually remarkably similar to the human, but because its function changes dramatically, so does the form. And then I will take a little bit of time to compare specifically the upper extremity, the arm, and the hand of the bat, this greater flying fox, with that of a human arm and a human hand. But very quickly, I'd just like to do a rundown here and go over a few things. So obviously we have our skull here. This is the skull, and you can see that it really resembles that of a fox. We have the long nasal bones, the mandible, the zygomatic arch. The brain case is back in here. And just like all other mammals, it's important to note that they have 7 cervical vertebrae. Only the manatee and the sloth vary from that in terms of mammals. So all mammals have 7 cervical vertebrae. So we have the atlas up here, the axis, followed by C3, 4, 5, 6, and 7. Then we have the thoracic cage. And if you'll note here, the thoracic cage is actually quite similar to that of the humans. We have the ribs, we have the sternal column, we have the collarbones. The scapula sits up here and actually sits on the back of the thoracic cage, unlike some of the other quadrupeds where the scapula fall on the side, it falls onto the back. So in that regard, their thoracic cage is very similar to that of the humans. You will note that the collarbones, the clavicles, rise up slightly different shape, and they're, in comparison to their body, they're quite a bit larger. And their sternum here, remember we have 3 portions to the human sternum. You can see it adjusts out, and it's much more of a keel. The reason being is one of the strongest muscles and the most important muscles for the bat is the pectoral muscles. So the pectoral muscles have this much larger surface in here where they will come through and connect onto the humerus. One thing that's a little bit different than the humans, we have 12 sets of ribs. The greater flying fox actually has 13 sets of ribs. They have an additional floating rib. They have 3 floating ribs in the back. So again, we have the skull, we have the cervical vertebrae, we have the clavicles, we have the thoracic cage, we have the sternum that comes through here. The scapula sit up here in the back. There's the acromion process where the scapula meets the clavicles. They will have 13 thoracic vertebrae because they have 13 sets of ribs. Then we have the lumbar vertebrae, and they also have the sacrum and the coccyx, which are connected to their pelvis. So basically, very similar structure to that of the human. Getting here to the arm, we have the upper arm, and this is the humerus, just like humans have. We have a humerus. Then we have the radius coming through here, and when we look at this arm in more detail in a little while, you'll see that there's an ulna on the back, but the ulna actually fuses onto the radius. It doesn't come all the way down. And then we have the little digits, the carpals. We have the metacarpals, and then we have the phalanges, and they're basically, their hands are identical to ours. Then we get back here to the pelvis again. We have the upper leg. This is the femur. They have a small little patella in here, just like we do. There is, coming down right through here, is the tibia. Then there is a little bit of the remnants of the fibula that comes here, and it fuses onto the back of the tibia. And this is where things get interesting. Imagine humans if we had our feet on backwards. The bat, instead of their feet coming out to this side, and they would walk and be bipedal, their feet actually come out, and they're completely in the opposite direction. And that's so that they can hang upside down when they're resting. So, as you can see, a lot of the anatomical structure is very similar between that of the human and that of the bat. One of the key things is the proportions here. It's important to note, and it's really interesting for me to think, imagine as humans, if we were to have hands that were larger than our entire body. So if you think about it, just the hand alone, this point from here out here to the end of the middle finger, is actually greater in length to that of the greater flying fox. The greater flying fox can be somewhere between a full-grown adult can be somewhere between 10 and 12 inches in length, about a foot in length. But they can have an arm span, or in their case, a wingspan of over 5 feet. This area right in here, just of what would be considered the hand, is probably it is for the most part greater than the length of the body. So if we hold our hand up to our face, basically our hand is about the size of our face. In their case, their hand is greater than the length of their entire body. So if we as humans had long arms and hands greater than our body and with a thin membrane attached, possibly we could also fly. So this is just a quick comparison and anatomy of the greater flying fox and how it relates to the human. What I'll do now is we'll have a little look here at the arm, followed by a closer look at the actual hand. And just to give you a sense of proportion, what I've done here is I've removed the wings so that you can see the size of the hand in proportion to the figure. So if you exclude the head, you can see that the hand in itself, which is the major portion of the wing of the bat, the hand is basically the length of the entire body of the greater flying fox. Imagine us as humans if our hand was this large. If you combine both the humerus, the radius, and the hand, it is significantly larger than the entire body of the greater flying fox. So it's really interesting to have this, to be able to see this in a sense of scale, so that you can see this is the hand. And then here we have right in here, so we have the fingers, we have the carpals, we have the radius, we have the ulna, and coming through here is the humerus. So we have the upper extremity, what would be the upper extremity in the human body, is significantly larger than that of the entire body of the greater flying fox. I love this portion of looking at the proportions. The proportions are fascinating, especially when we start looking at different animals and different species. And you can clearly see how form is dictated by function. So I thought you'd find this interesting to see the direct correlation between the proportion of the upper extremity, the size of the upper extremity, and that of the body of the greater flying fox. Thank you. So this is a little bit of information comparing the human arm to the greater flying fox. As we can see here, this is the human arm, the upper extremity. This would be the arm, or in this particular case, the wing of the greater flying fox. It is the largest of the mammalian bats. So this particular section right in here, this is the humerus. And this section right in here, this is also the humerus. This is the humerus of the greater flying fox. So as you can see, the structure is relatively the same. Right here is the olecranon. That is the back of the elbow. Here we have the olecranon, and that is the back of the elbow, and that is the top portion of the ulna. So this thin little area that we have coming right through here, that is the ulna. You'll notice on the bat that it does fuse onto the radius. It does not come down, so you cannot see the styloid process of the ulna, or the head of the ulna in this particular case. You have this little bony process out here that was the remnants of the head of the ulna. However, it does fuse up in here, and it comes down right through here, and it completely fuses on. So it's something that over time has not become necessary. So we have the humerus, we have the ulna, we have the large radius, we have the styloid process of the radius in here, then we have the little carpals, and then we get into what is the hand of the bat, and would be very similar, if not almost entirely identical, to that of the human hand in terms of the bone structure, the osteology of the hand. So head up here, head of the humerus, head of the humerus of the bat. We have the shaft of the humerus, we have the shaft of the humerus, we have the lateral epicondyle and the medial epicondyle. We have the lateral and medial epicondyle down there of the humerus. We have the olecranon, there's the head of the radius, there's the head of the radius here, then we have the shaft of the radius, the shaft of the ulna, and again it fuses, and then we get down to the end, there's the styloid process of the radius, there's all these little carpals, all the little carpals through here, and then we get to the hand. So the thumb is usually known as digit or phalanx number 1. So this would be digit number 1, digit number 2. The middle finger is digit number 3. This would be the ring finger, digit number 4. And this would be the pinky, digit number 5. Just the same as that we have here on the human hand. See if I can tilt that just a tiny bit so we can see this. I don't know if it'll stay. But the interesting thing to point out is on both the thumb and the pointer finger of the bat, there is a small talon. Humans have fingernails at the end, and they will have, on those two particular fingers, they have a small talon. So again here, this is the thumb. This is the metacarpal one. Then they have metacarpal 2, metacarpal 3, metacarpal 4, metacarpal 5. Then they have, just like we have, the proximal phalange and the distal phalange in the thumb. They also have the proximal and the distal. And right here, they have the proximal, medial, and distal on digit number 2. And see, we have metacarpal, then we have proximal, medial, and distal phalange on digit number 2. Digit number 3, they have the same. They have proximal, medial, and distal, and same with the ring finger and the pinky. So it's quite fascinating that basically, if you think proportion-wise, their hands are larger than their entire body, whereas our hands are basically the same size as our face. If their hand was the same size of that of the head of the greater flying fox, they would not be able to fly. And if you turn their feet around, they may be bipedal and just look like extremely small versions of humans. But again, it's really curious and it's fascinating how we function. Our form dictates our form, the way we're developed, is dictated by our movements, by our form of locomotion. So function determines form. That's always an important thing to remember in terms of comparative anatomy. Function determines form. So just a quick rundown again. We have the humerus, one bone, followed by two bones, followed by little bones, followed by digits. It's very common in the mammalian world. One bone, followed by two bones, followed by little bones, followed by digits. Humerus, radius, ulna, carpals, metacarpals, and phalanges. Humerus, radius, ulna, carpals, metacarpals, and phalanges. So that's the comparative anatomy and the similarities between two completely different mammalian species. Again, remember, the bats are the only mammalian species that has the ability to fly. There are a couple of animals that have the capacity and ability to glide. They can jump from trees or high areas and they can glide around, but they cannot actually fly. Bats do have the capacity to fly. So that's a little comparative anatomy showing the significance of the upper extremity and comparison between the human anatomy and that of the greater flying fox. I hope you enjoyed this and found this fascinating. Thank you.